says a squared plus b squared equals c squared. And we learned that the c squared is the hypotenuse. It's the longest side. It's across from the longest or biggest angle, the 90-degree angle. So we can always find it across from the 90-degree angle. That would be the c. A and b are the sides. Doesn't matter which one. So all of these you might think are sides, but in math, this one has a specific name, hypotenuse. That would be the c. And so we plug in these numbers in school, and this is all I knew how to do. I didn't know where it came from or what it was talking about or how it's applied in maybe how they began to understand it visually. So we have a right triangle. We have some numbers. Let's make it easy. We're looking for the hypotenuse. We have 3 and 4. Okay, this is a famous Pythagorean triple. Each number is going to come out a whole number. So we go across from the 90s, our hypotenuse, and we say 3 squared plus 4 squared equals the hypotenuse squared. Now we had learned that something squared means 3 times 3. Okay, because you're really saying, what's a square with a side 3? 3 squared. Well, it would be a 3 by 3, which gives you 9. 3 squared is 9. So 3 times 3 is 9. 4 times 4 is 16, which again, doesn't matter if you know this, but it's talking about a square. If you have a 4 by 4 square, 4 squared, you have 16 little squares. 16 is 4 rows of 4. Equals x squared. We added them, and we told you opposite of squared is square root. To balance it, x equals square root of 5 times 5. We were told when you have 2 of them, it becomes 1. Well, again, it's because you have 25 of them. What's the square root? What's one of the sides? Would be a 5 by 5. So you turn a 5 by 5, you want to know what's one of the sides, would be 5. We use only one of the 2 numbers. Okay, so what is the Pythagorean theorem other than using it numerically? Which again, if you had to draw these bricks every time, you would run out of room and get frustrated. So we're allowed to compute and do things we don't even have to imagine in math. It turns you into a computer. So let's look at the Pythagorean theorem and how he found out, or how somebody, probably a she, the way history is written, women tend not to get credit, even though we know they were pharaohs and leaders and queens. So let's take the one we just looked at, a Pythagorean triple. It said 3 squared plus 4 squared equals something. So this is what Pythagorean was talking about, and more than likely they actually used little pebbles or stones to talk about it. If you have a 3 by 3 square, 3, and a 4 by 4 squared, a 3 squared, or 3 by 3, gives you 9. A 4 square is a 4 by 4, gives you 16. How many would you have that can fit here? So what's interesting is the actual shapes will fit here. So this is what we're looking at. We just finished writing what is 3 squared plus 4 squared equal. How many squares? So the hypotenuse is going to sit off here to the side. A 3 square, a 3 by 3 has 9, plus a 4 by 4 has 16. So what do we have? 25, right? 16 plus 9 is 25. We have a square with 25. We have a squared of 25. So c squared is 25 is a way to explain what I'm saying using symbols. A square with 25 little blocks gives you how many on each side? Well, each side would be 5 because the square root of 25 is 5, a 5 by 5. So imagine if you had to draw this out every time you did it. I mean, we could do 10 squared plus 8 squared and calculate this in a minute. What if we had to spread this out and actually measure and observe each time? Someone found the formula that allows us to skip that very lengthy process. We could do 135 plus, whatever the gigantic number is. And we could actually calculate the number of little blocks in each square, or how many blocks are in each side of a square. So a squared plus b squared is saying the sides of the triangle, 3 and 4, if we made a square out of it, what would that give us? And we're beginning to explore geometric growth and geometric shapes, which will allow us to then jump, once we understand it, to three-dimensional shapes like cubes. And it's very important for any architecture or design to have understood this in order to get to where we are today. The basic building blocks of a right triangle. Now, those who go further will understand that every right triangle is simply a position on a wave, on the circle, on the unit circle. So what we're beginning to also understand is the unit circle and the wave, which will lead into physics. So very basic concepts will build and be used in higher, more advanced classes. We want to understand them. So the Pythagorean Theorem in a square is talking about real squares, and the root is asking what is the root of one side, not both. So we take one of the sides. The Pythagorean Theorem is talking about actual shapes. You could get little blocks out and get the answer, but if you did that, it might take you an hour, depending on how big the number is. So the math allows us to do a shortcut to compute and calculate things using a small amount of time and paper, considering how long it would take otherwise. So it does take time, but it saves up a lot of time.